So this is just a continuation of finding the domain and range from graphs in section 2.5. And the 4 graphs that are on the sheet right now, they don't need to be extended because each of the edges is marked with a point. And that's my favorite kinds of domains and ranges. They're the easiest. Don't have to worry about extending to any infinities. So in problem 18, the only 2 points are marked. Those are the only points I need for the domain and the range. And I don't need to extend the graph. I just need to find the left edge of the graph, new marker, and the right edge of the graph. If I could actually make it the right edge. So I have my left edge and my right edge, drawing vertical lines. I'm going to pick off my x's and get my domain. So the numbers that I'm going to need for my domain are the x's that these vertical lines touch. X equal to -2 and x equal to 1. I read from left to right when I do my domain. Both the points are marked with a closed circle, so both of my brackets are going to be solid. Now I'm going to go the other way, find the bottom, horizontally as opposed to vertically, and the top. And now I'm going to find the range. The range, I go bottom to top and I pick off y values. So the bottom point has a y of -3. The top point has a y of +6. I don't know if that looks like +6, but it is. So the numbers I need for my range will start at y equal -3. It will end at y equal to 6. These are also both square brackets because each of the points is marked with a closed dot. I almost think we should do 19 together because I have to do some estimating. I don't know how to make round circles using the programs that I make graphs with, like these graphs. So I'm limited to what I can find on Google Images until I figure out how to do this. I guess I could just open up a graph on my iPad and put a circle in, but I haven't got that advanced yet. So let me work with 19. And in 19, both edges are marked. They're marked with open circles. This graph doesn't extend beyond what we see on the screen. So in problem 19, left edge is right there, right edge right here. So this is the left edge, this is the right edge, and the person that wrote this didn't mark the point very well, but I know how to make points. To get to this point, I start at the origin, I go left 2 and down 2. This is the point -2, -2. This point, it's right 2, down 2, the x is 2, the y is -2. So now the points are labeled well enough. So now I'm going to describe the domain. The domain goes from, the numbers in my domain are the x coordinate of the left edge, which is -2, followed by the x coordinate of the right edge, which is 2, and point marked with an open circle gets a round parentheses. Both of those points are marked with open circles. I get double round parentheses. Range is harder because I have to estimate, and I don't like estimating, but it is what it is. Here's my bottom of my graph. There's the top of my graph. I need to estimate this point. It doesn't matter if I estimate the x poorly because I only need the y, and the y is going to be -4. This x is maybe -1.5. I'm going to call this point, which is an unmarked point, -1.5, -4. That's the point that is at the bottom of my graph. And this point right here, again, I don't need to be that accurate in terms of describing it. I'm going to say the x is between 1 and 2. Maybe the x is about 1.5. And the y, points on the x-axis, the y is 0. So that might be more advanced than I should have right now because we haven't done much graphing, but it is what it is. So for my range, the bottom point, I need its y for my range. I'm going to go from bottom to top and pick y's. The numbers I'm going to need for my range are the y coordinate of the bottom point, which is -4, the y coordinate of the top point, which is 0, and now I need to get the brackets. These both were unmarked points. Unmarked points on the graph get square brackets. That's why I wrote this up, because I knew it was going to be a deal. All right, just checking my answers before I dump this sheet off. Our problems are pretty similar. 21 and 22 are pretty similar. My problem 22 has a solid circle marked on the left, an open circle marked on the right. Let me try to estimate this point for you. The closed circle on your graph, I think it's -2, -3. The open circle on your graph, I believe that's 5, 1. I need to do the same on mine. And so this point right there, it looks like it's right between -4 and -2. I'm going to say that's the point -3, 0. And this point, it's at 5, and it's 1 above 10, so I think it's 11. So I need to know the points when they're not marked. Again, when you see open circles from me, you're going to find that I stole the graph from somewhere because I don't have that technology. So I'll work on 22. I'll do my left edge and my right edge. I don't need to extend the graph because both sides are marked with some sort of circle. So for my domain, I'm going to take the x's of -3 and 5, which are the x on the left edge, the x on the right edge. The first point's marked with a closed circle, I get a square bracket. Second point marked with an open circle, I get a round bracket. For the range, I need the bottom of the graph and the top of the graph. And once I find the bottom and once I find the top, I pick off the y's. The y coordinate at the bottom of my graph is 0. The y coordinate at the top of my graph is 11. The bottom 0 came from a closed circle point, so it gets a square bracket. The top 11 came from an open circle, so it gets a round bracket. Let's do 23 together. None of the points are marked, and I'm going to need to maybe mark some points, and maybe I'll help you out there. So maybe pause the video and see if you can do it. Hopefully the font's big enough. If not, let me box this in. I don't need to extend it because each of the ends of the graph are marked with a circle, or they clearly don't extend. The left edge, these little points don't go on forever. So this is my left edge. This is my right edge. I need to know what these points are. Here's an unmarked point. It goes through -4 on the x and -2 on the y. That unmarked point is -4, -2. This marked with a circle point is 3 on the x, 5 on the y. When I go to write the domain for this, the numbers I'm going to need are the x's from the edges. So this -4 and that 3. Unmarked points get a square bracket. The 2 times I get a square bracket, points marked with a closed circle, unmarked points on graph. 2 times I get infinities, point marked with an open circle or an extension to infinity. So for this, this point is an unmarked point, it's a square bracket. That's an open circle, it's a round bracket. When I go to do the range, I need to bottom out my graph, top out my graph. I already have the point on the top labeled. I didn't take the time to label the bottom point because I didn't know I was going to need it. That point is 2 for the x and -5 for the y. So I've identified the bottom and the top. I'm going to plug off the y's. My range is going to start at -5, end at 5, because those are the y's from the bottom and the top points on the graph. Both of those points are marked with open circles. So my range has to be double round parentheses in 23. I think our graphs are a little bit similar. I think 26 is harder than 25. Let's do 25 together. Try to figure out the left edge and the right edge. This graph needs to be extended because of the little arrow at the end. The left part doesn't need to be extended. The left part's going to be the bottom and the left edge of my graph. But this graph needs to be extended. And because as I'm extending it, my graph is going right and up. Because it's going right as I'm drawing, I'm going to extend it to the far right edge of the x-axis, which has a positive infinity. And because it's going up as I'm drawing it, it's going to extend to the top of the y-axis, which has a coordinate of infinity. I'm going to need this point. This is the point -2 for the x, -3 for the y. Let me box my graph in. You don't have to draw these in. I just kind of like to do it because I think it makes it more visual for those of you that are visual. So this is my left edge. This is my right edge. I'm not even going to write left and right edge. And with the left and right edge, I can pick out the domain. If I plunk out the x's, the first x I'm going to take is the -2 from that point, -2, -3. The second value I'm going to take is the infinity from the far right edge of the x-axis. Infinities always get round brackets. Points marked with open circles also get round brackets. Now I'm going to box a bottom and a top. That point that's marked is the bottom of the graph. There isn't a top of the graph. The graph goes up to the top of the y-axis, which is, positive infinity. So the numbers I need are the -3 from the y on the bottom and the infinity on top of the y-axis. So I'm going to go -3, comma, infinity. Infinities always get round brackets. That point that gave me the -3 was an open circle, so I get another round bracket. All right, so I'm going to need to do some estimating for you on 27 just in case you can't see this. And this point right here, I don't know what it is exactly in terms of the x. I'm going to call that point -2.5 and -2. Turns out it doesn't matter how accurate I am with the x because the x won't be needed, but I need to have the y accurately. And this point, another unmarked point, I'm going to call that the point 2,4. There's an open circle here at the point -5, -1, and a closed circle here at the point 4,3. So when you go to do 27, those are all the points that you're going to need. Again, maybe this isn't perfectly accurate on the x, but I didn't need to be that accurate on the x. So you should be able to do 27. I'm going to do 28, and again, I'm going to mark the points. Anything with an open circle I've just stole, and I just can't find something up to the quality that I want, so I just live with what I can get. So this open circle point that's the left edge of my graph is the point -3,2. This closed circle graph is the point -2,2. And this graph extends. It goes down and to the right, which means because it's going to the right, it extends to the far right edge of the x-axis. Because it's going down, it extends to the bottom of the y-axis. So if I'm working 28, I draw my left edge in, or I think of my left edge. I draw my right edge in, or I think of my right edge, because there really isn't a right edge. This graph goes down and to the right forever. And I'm about to write my domain for 28. I look at my vertical line at the left edge. It goes through -3 for x. And my ending line goes through infinity on the x-axis. Infinity always round brackets. That point's marked with an open circle, so the -3 also gets a round bracket. And now I'm going to go through the bottom of my graph. There's not really a bottom, I'm just calling that the bottom. And the top is actually at this point. That point there is higher than the point that I used for the domain. So my starting range is going to be -infinity. My ending range is going to be the y of that, which is 2. Infinities always get round brackets. That point was marked with a closed circle, so I'm going to get a square bracket. Let me scribble an answer up for you for number 27, so just in case you were wanting to check this. For 27, I have the domain written as -5 round bracket, 4 square bracket, and I have the range for 27 written as -2 square bracket, 4 square bracket. I believe those are both right. (29) and 30, both edges need to be extended. Neither edge of the graph is marked with a period. So the left edge for number 30, I'm going to extend it. And as I'm extending it, my graph is going left. So it's going to extend to the far left edge of the x-axis, and my graph is going up, so it's going to extend to the far, or to the top of the y-axis. The other portion of the graph, as I'm extending it beyond the screen, my pencil or my marker is going down, so it's going to go to the bottom of the y-axis, and my marker is slowly going to the right, so it's going to extend to the far right edge of the x-axis, which is +infinity. That's the extension I need. I need double extension, and the points that are marked are distractor points. So this graph, its left edge is going to be at -infinity, because this graph is going to go up and to the right forever. Eventually it's going to pass this line, but this line just kind of signifies the right edge of where I can get to. And it's going to go like that again. This graph is going to go forever. Eventually these will meet up. There is no right edge, there is no left edge. The edges are infinity. So when I go to write my domain, the vertical lines that I've just drawn go through -infinity and +infinity, double round parentheses, because infinities always get round parentheses. When I go to do the range, I find the bottom of the graph. There really isn't a bottom, but that's what I'm calling the bottom. And of course the graph goes above this, but I'm calling that the top. And again, those are extensions to the infinities. So the bottom of my graph, which I read first, starts at -infinity. Top of my graph goes to +infinity. Infinities always get round brackets. So that's an important skill, to be able to find the domain and range from graphs. Come up quite a bit in college algebra, and it comes up a lot in calculus. So it's going to be a useful skill, and we'll move on to some more stuff in the next section that you actually see more so in calculus than in an algebra class usually.